Hey, it's Trip here from the 87th. This is a video of a flight in IMC conditions from Osan to Seosan in BMS 4.33. Information is current as of update 1. Earlier I made a two-part video of the ILS system in BMS, and it was a lot of freezing and explaining and unfreezing and freezing again and explaining and so on, and I thought, well, wouldn't it be nice if I could just make a video without talking in real time and just fly the departure and arrival on a short IMC IFR flight and just let you follow along on the departure and the approach diagrams and see where we are and how what it looks like on the HSI. So that's what I'm going to attempt to do here. But this is also a two-video series with the same name. I think I'm going to call it IMC Flight and BMS. So look for that. But the first part is a discussion of the departure and arrival procedure and give you an idea of how the flight is going to be conducted. And then the flight itself, the second part, I'm going to try not to say anything, just be as quiet as I can, just like you're riding along and looking over my shoulder and just, you know, watching what I do. And if I say anything at all, it's not meant to be instructional. It's just me thinking out loud and giving you an idea of, you know, what I'm thinking now and what I'm thinking has to happen next, and trying to stay ahead of the airplane. And so I'll be as quiet as I can, but I know that's hard for me to do sometimes, but I think it'll be fun. Alright, so in this first video, let's talk about this Jet Yoke 4 departure. It's out of Osan. We're going to be departing on runway 27. That looks like a more interesting departure. The first thing I notice is the TACAN up on the strip, briefing strip up at the top. And there's a box that says TACAN 94 X-ray. Well, it's interesting. I've noticed that in Falcon 4, ever since I started playing Falcon 4, if you take off and land at a destination that's different from your departure field, Falcon 4 always sets the destination field TACAN. So in this case, they're going to be setting 52 X-ray in the DED when we get in the airplane, instead of 94 X-ray. Well, we need 94 X-ray. We need the Osan TACAN to fly this departure procedure. So be very careful of that. If you take off and land at two different air bases, just exactly what the TACAN is set on. Alright, if we look at the route description down below in the text area, it says take off on runway 27, climb on a track of 265. Well, the track means I have to have some course guidance. So the course guidance is going to be the Osan TACAN. So now I'm double checking that I have 94 X-ray set. And it wants us to go out to 3 DME and then make a left turn and track 190. Well, I can't really track 190 because I don't have any course guidance once I make that turn to 190. It looks like it might be an extension off of Seosan TACAN up there at the top of the chart, but it's not. It's just a heading of 190. And it wants us to intercept and proceed via the 220-degree radial from Osan and then onto the 20 DME arc and then arc around to Crown intersection. And so that's what we'll do. Now, my clearance for this approach, it's a tower en route clearance, meaning we're only going to be talking to tower. So about halfway down, ATC is going to clear us to Seosan Tower, and I actually am ATC. So anything that I request, I'm going to be granted. So it's good to be ATC. So yeah, so halfway down, we're going to switch to Seosan Tower. Now, down at the bottom of this plate, it says, if not VFR on top prior to crown, enter holding and climb until on top. Well, ATC, once again, has granted us a waiver from this restriction, so that won't apply during this flight. So I notice I'm going to turn to 190, intercept to 220. So I'm going to have 220 set in the HSI as my outbound radio from Osan TACAN. Make sure the instrument mode selector is set to TACAN. And now I'll have a nice picture on the HSI of just exactly when I'm on the 220. When the CDI centers, then I just turn to a heading at 220 and off we go. I need to lead that turn from the radio onto the arc, and in the ILS video I talked about that. So I'm going to use, since I'm doing 280 knots, that's what I plan on flying this departure at. That's almost 300 knots, and I'm going to take that as my ground speed. So 1/10 of my ground speed is 3. I'm going to express that in nautical miles. So 3 miles prior to 20, about 17 miles is where I'm going to start my left turn onto that 20 DME arc. The other thing is our altitude clearance is going to be 6,000 feet. So I'm going to hold about 1,000 feet per minute after takeoff at 280 knots. If I was to hold mill power and climb at 300 knots, I'd probably be doing, well above 3,000 feet per minute rate of climb, and I'd blow right through the 6,000 feet before I knew what happened. So I'm going to try to slow things down, both with my speed and with my vertical climb, and so I don't let things get out of hand too much. All right, I notice on this arc, taking off on runway 27, the arc is very short distance from the 220 radio to crown, and so I'm wondering, well, how much time is it going to take me to cover that distance? And so the way you figure that is you need a couple pieces of information. First, you need to know how many degrees of bearing change there is between the time you get on the arc until the time you get to crown. Well, crown is the 186 radio off of Osan, and and we're already established on the 220. So if you subtract 186 from 220, you get 34 degrees. So 34 degrees of bearing change there. The next piece of information you need to know is how many degrees of bearing change equals 1 mile. Well, if you take the arc distance, which is 20 miles in this case, 20 DME arc, and you divide that into 60, you get 3. So now every 3 degrees of bearing change that you make, you've traveled 1 mile. So if we have 34 degrees of bearing change total, and we're doing 3 degrees per mile, if we divide 3 into 34, we get about 11. So that's 11 miles from the 220 over to crown intersection as we fly on that arc. Well, that's interesting, but doesn't give me any real useful information until I figure out how much time it's going to take me to cover that 11 miles. And the easiest way to do that is to look in the HUD at your Mach number up in the lower left corner of the HUD, I guess it is. If we're doing 280 knots, that's going to be about 0.55 Mach, and that is a very good approximation of your ground speed in nautical miles per hour. So you round that down in this case. So 0.5 is going to represent 5 nautical miles per minute. If you were doing 0.8 Mach, you'd be doing 8 nautical miles per minute, and so forth. So it's just a good something to a little gouge to have available there. So if I'm doing 5 nautical miles per minute and I got to go 11 miles, it's going to take me about 2 minutes to cover that distance from the time I turn onto the arc until the time I get to crown intersection. So that's useful to know. That gives me an idea of if I go much more than 2 minutes, then something's wrong. I've passed crown intersection. And as a matter of fact, speaking of the crown intersection, there's nothing on that depiction there or in the route description that says I have to intercept the 186 degree radial outbound once I get to crown. So what's going to happen is when I'm on the 20 DME arc, when the 186 degree radial centers on the HSI, then I'm at crown intersection, and from that point I'm free to proceed on course. The route description says, the last thing it says is thence. So the thence means proceed on course or ATC vectors or whatever. So in this case we're going to be proceeding to steer point 2. All right, I think that's what I want to say about the Osan departure. Let's look at the arrival into Seosan. It's the ILS to runway 02 right. So we're going to be coming down from the north, and I'm going to request and be given a clearance to proceed direct to Sapke intersection. That's the initial approach fix. That's where the approach starts. That's the start of the arc. And the way I'm going to do that is I'm going to hijack our steer point 2. So I'm going to change the coordinates for steer point 2 to those coordinates you see there, the north and east coordinates. And now I got to make sure that I'm in the nav mode on the instrument selector, and that's going to take me direct to that steer point 2 that I made. And once I get to Sapke, I'm coming down from the north. I'm just going to turn left to an outbound heading of 135. See if I can make this a little bigger. 135 is the reciprocal of the 315, the inbound course to Sapke, and holding pattern there. So I'm going to turn left to 135 and wait about 4 or 5 miles, and then another left turn and intercept that 315-degree course inbound to Sapke. Now that'll be on the TACAN because that's reference to the TACAN. So I've got to switch to TACAN on the instrument mode selector to make that intercept of the 315 inbound. And that's not a problem. This is why we hangar fly the departure and approach. We just get it all squared away in our mind as to what we need to do, and we look for trouble areas and so forth. So it's good to hangar fly this before you get in the airplane in real instrument conditions. Alright, the next thing that's going to happen here is I need to start a descent as I start my left turn onto the arc. Now there's a 10,000 foot there in the holding pattern. It doesn't say it's a minimum holding altitude, doesn't say anything really, so it kind of leads me to believe that I need to be at 10,000 feet when I hit Sapke, as a minimum altitude. Well, again, ATC has approved my request for 6,000 feet at Sapke. So now I only have to lose on the arc, I only have to go down from 6,000 feet down to 5,000 feet, which obviously is not a problem. But let's say I needed to go from 10,000 feet down to 5,000 feet during that time that I'm arcing around. What kind of rate of descent do I need to achieve that? Well, again, if you just do some simple math, the distance from Sapke to the end of the 12 DME arc is a distance I need to know in nautical miles. So I just take 200, which is the radial there where the final approach course begins. That's the reciprocal of 0 to 0, 200 radial. I'm starting at Sapke on the 135, so I subtract those, I get 65 degrees of TACAN bearing change. And again, I take 60 and I divide it by 12 in this case, because the DME arc is 12, so 12 into 60 is 5. And if I divide the 5 into the 65, I get 13 nautical miles. So every 5 degrees of bearing change is 1 mile, so 5 into a total of 65 degrees of bearing change is 13 nautical miles. So it's 13 nautical miles, the total distance that I'm traveling over the ground from Sapke to the end of the arc. So if I have to lose 5,000 feet, that is go from 10,000 feet down to 5,000 feet, that's 5,000 feet divided by 13, and that's 385 feet per nautical mile. So I have to lose altitude at a rate of 385 feet per nautical mile. Now if you'll write this down on a piece of paper, it'll make sense. Just put x over 385 equals 230 over 60. The 230 is my ground speed. That's the calibrated airspeed roughly that I'm going to be doing on the arc for this approach. That's a good, comfortable speed. Alright, so you multiply that out, cross multiply, and you get a rate of descent of 1475. Now that's in feet per minute. That's something I can use. And we'll round that up to 1500. So when I hit Sapke, I'm going to start my left turn onto the arc and descend at the same time. I'm going to descend at a rate of 1500 feet per minute. And it'll be a nice comfortable descent. I've got 13 miles to lose 5,000 feet if I was to start at 10,000. But again, today I'm going to start at 6, so it's not an issue. But it's good to calculate these numbers, and the reason is in the next step down, it's kind of an interesting thing that's going to happen there. I'm not allowed to go below 5,000 feet till I'm 12 DME and I'm inbound on the localizer course. And then I can go down to 3,500 feet by 9 DME. So I've got 3 miles to lose 1,500 feet. And if you do that same calculation, that's 500 feet per nautical mile. So if you set up the formula x over 500 is equal to 230 over 60, that works out to be 2,000 feet per minute rate of descent. So that gives me an idea of the rate of descent I need. It's not so much a problem there in that segment, but in the next segment, when I go from 9 DME to 6 DME, I've got to lose 1,500 feet again. But this time, I need to be down sooner than just arriving at 6 DME at 2,000 feet. I need to be at 2,000 feet and then driving level into the final approach fix, into the glide slope intercept. I want to intercept that glide slope from below, so I don't just have to be doing 2,000 feet a minute. I probably want to be doing closer to 2,500 or 2,700 feet per minute. So that's important, because if I had planned it so that I left 3,500 feet at 9 and I arrived at 6 DME at anything higher than 2,000 feet, then I would be intercepting the glide slope from above. In the ILS video, if you watch that, it'll explain why that's not a good idea. So we always want to intercept glide slope from below. So I need to get down to 2,000 feet in an expeditious manner. So this calculation tells me, gives me a number that I can use. In this case, 2,500 feet per minute. I need to pick up 2,500 foot per minute rate of descent and get down there before I get to 6 DME. Now, speaking of when to descend, all these fixes, like for instance, I'm at 3,500 feet at 9 DME and I'm going to descend down to 2,000. When you're 3/10 of a mile from any one of those fixes, you can start your descent. So in other words, if I'm driving in from 12 DME on final and I come up to 9.3 DME, and that's read up in the HUD, by the way, and I'll explain that in the ILS video also. You can't read that on the HSI intents, but you can read it in the HUD. When it gets to 9.3, then I can start pushing the nose over and pulling the power back and picking up that 2,500 foot per minute rate of descent. So it kind of puts me ahead of the game here. So it ensures that I can get down to 2,000 feet by the time I get to 6 DME. Alright, so good on that. Let's pan out here. So we'll fly the ILS approach just like I described it in that ILS video that I made. Now I don't know what the weather is. I know what the weather is going to be. It's going to be very low visibility and low ceilings. I don't know that at the decision altitude that I'm going to be able to see the runway and land. As a matter of fact, even if I can see the runway and land, I'm just going to make a missed approach and fly the published missed approach procedure just to make sure your fun meter is pegged out. So let's look at that missed approach procedure. It says climb straight ahead to 3,000 feet until reaching 4 DME. Alright, and then we make a left climbing turn to 5,000 feet and turn to a heading of 200 until intercepting the 315 and bound to Seosan, and then track outbound on the 135. Okay, interesting. I climb straight ahead at 3,000 feet. I'm going to do 280 knots again and 1,000 foot per minute rate of descent, so I can slow things down and get things under control. At 4 DME, I'm going to turn to 200 and level off at 5,000 feet. Now it's a problem for me that I see here, and this is why we hangar fly, so that we don't have to figure these things out in flight, when they're actually happening. If I'm on a heading of 200 and I approach the Seosan TACAN, that turn point to intercept the 315 radio inbound, which is the 135 course inbound, that is problematic because the head of the bearing pointer is going to be moving very rapidly. That's probably, at that turn point, it looks like about a mile or a mile and a half from the TACAN station. And the head of the bearing pointer is going to be moving very rapidly. I'm not going to be really sure when to start my turn, when to lead it. If I'm too late, then I'll overshoot the turn point and I'll wind up south of the TACAN and then have to intercept the 135 outbound from the south, have to correct back to the CDI. Or if I try to turn too soon, then I'll be on the north side of the TACAN and have to turn right to intercept the CDI. So what I'm going to do is, at 4 DME, I'm going to make a continuous left turn and proceed direct to the TACAN. So I will avoid that problem there at the corner of overshooting or undershooting. So as soon as I get the needle swing on the TACAN, as I approach the station, then I'll turn to 135 and I should have an easy time of intercepting the 135 radio outbound. And I can do that because all that space between, well, where you see it says 4 DME and heading at 200, all that airspace in there is protected airspace, so I can essentially make a turn and go direct back to the TACAN. Alright, so that's what we're going to do. A lot of talking here, but the next part, the second video, is going to be real time, and I hope you enjoy that and get something out of that. Alright, thanks, and trip out.